So we've been looking at different ways that light can interact with materials, and last time we looked at reflection. Now we're looking at refraction. And refraction can only happen if light goes all the way through a material. So that means it only happens for transparent materials. And in other words, the light has to be transmitted, meaning it goes all the way through a material. So refraction happens because scientists discovered that light moves at different speeds in different materials. So light moves at different speeds. And the speed that light moves through a material is called the refractive index. Which is, in other words, how much does a material slow light down? And some examples of refractive index are air, and air has a refractive index of 1. That's the normal measurement that we use to compare other materials. Water, it's harder for light to move through water, and you can picture yourself moving through it too. It's much easier to move your arm through air than it is through water because it's more dense. And water has a higher refractive index, so light moves slower in water. And then another material that's even more dense than water is diamond. So diamond slows down light even more, and it has a refractive index of 2.42. So light moves faster in air and much slower through diamond. So because light moves at different speeds, this causes refraction if it hits on an angle. And let's look at a couple of diagrams to show this. So if we have the boundary between air and glass, we might be zooming in at the window of your house. So here's the boundary in the middle. As light comes through air and hits the glass, it slows down as it goes through the glass. But in this example, if the light hits directly head on with the glass, or in other words, at 90 degrees, nothing changes. It slows down through the glass, but we don't see anything if we're looking at it. But if we have another example with air and glass again, if the light comes in on an angle, what actually happens is the light ray bends as it slows down through the glass. And this is what refraction is. So refraction is light bending as it crosses the boundary between materials. Light bending as it's transmitted. So let's look at an example of how we can picture and explain why the light bends. And one way of doing it is to look at a car as an analogy. So with our car, let's look at the red one first. here we've got the normal road, and at the bottom we've got sand. So this is representing the light going through air and then going through glass, which has a higher refractive index than air. High refractive index and low refractive index. And if we think about it in real life, if a car's driving along the road, it has good grip with the tyres and it will move fast. But once you try and drive on the sand, the car slows down a lot. So as it drives along, it goes fast along the road, and then it slows down as it drives on the sand. But because the car's going exactly at 90 degrees, nothing really changes with the way the car's driving. But in our next example, the car's driving in on an angle. So as it drives along the road, eventually it hits the boundary between the road and the sand. And if we zoom in at the exact point where the car hits the boundary, and we can draw the car here, only one of the wheels hits the sand first, which is the right-hand wheel here. So this wheel slows down before the other wheel does. The other wheel is still going fast. So this means the car turns a little bit to its right. And it keeps turning until the other wheel hits the sand as well. And then it will keep driving straight ahead again, because all the wheels are on the sand. So because only one side of the car hits the sand first, it turns. And this is exactly what happens with a ray of light when it's refracted. We have the surface, we have a ray of light coming in, and one part of the ray of light hits the surface before the other part. So it bends before the far side. And overall, the light ray bends, which is how refraction happens. Another common place that we can see refraction is when you're looking at something into water or that's underwater. And you might have noticed when you're at the beach, if you look down at your foot or at a fish, something underwater, it actually isn't, it appears to be in a different place to where it really is. And this is because of refraction again. So if we look at the fish down here, the light hitting the fish comes up through the water until it hits the boundary between the air and the water. But then it bends or it refracts. And in this case, it refracts to the right and then into our eye. But our eye only thinks objects are straight ahead. So our eye looks and continues that line straight ahead, and we see the fish here, which is much more shallow than it really is. And these are called illusions, where objects aren't where they are in real life, or they seem to be in a different place. And you can see another example of an illusion here when you put a pen inside a glass of water.